Pole vaulting began as a mode of transportation, not a sport. In Europe, men would use poles to propel themselves across bridgeless canals. In the late 1800s, pole vaulting caught on as a college sport. The athletes used bamboo poles to vault themselves over a horizontal bar. Today's poles are incredibly lightweight, yet strong enough to absorb the vaulter's energy, then throw it back to propel him over the bar. Some poles are made of carbon fiber, others out of this material, resin-impregnated fiberglass. The first step is to spread out the material and cut out the pole pattern. Meanwhile, a slitter machine cuts the same material into strips of a specific width. Then it winds each strip into its own roll. This spiral wrap machine automatically unravels the strip and wraps it around a hollow steel tube called a mandrel. This first layer of fiberglass gives the pole its flexibility. They wrap a second layer in the opposite direction. For the next layers, they remove the mandrel and lay it on a table. Now it's time for those fiberglass patterns they cut earlier. They heat the edge of the first one with an iron, melting the resin in the fiberglass until it's tacky. They stick this edge to the mandrel, then slide the other end between heated rollers. The rollers wrap the rest of the material around the mandrel, the heat activating the resin in the process. The mandrel and its multi-layer fiberglass coat now go into an oven. The heat generated by steam starts at 175 degrees Fahrenheit. This liquefies the resin so that it resaturates the fiberglass. Then the temperature gradually rises to nearly 300 degrees, solidifying the resin again, curing it. And when it finishes, a pole extractor slides the mandrel out of what's now a fiberglass pole. The pole moves onto a flex machine. In part, this is a stress test. If there's any type of defect, the pole will crack or break. But the flexor also permanently puts a specific degree of curve in the pole, which helps the athlete vault higher. Now they make what's called the soft side mark. This helps the pole vaulter locate the bend in order to know where to grip the pole. Next, they apply a maximum weight label, indicating how heavy the vaulter can be. To finish the surface now, they mount the pole on a spindle, then run a polishing pad over it. Then, using a solvent, they clean off the debris. Now that the surface is pristine, they wrap it in thin, lightweight tape. Different colored tapes designate different pole styles. They cap the top of the pole with plastic. Then at the bottom, mallet on a molded tip made of hard rubber. The finishing touch is the manufacturer's decal. Vaulting poles come in various lengths between 10 and 16 feet. A pole designed for a heavier vaulter has to be stiffer than one designed for a lighter vaulter because the pole has to propel more weight with the same degree of bending.